this video I'm going to take you through what we did in class for 9.6, and this is probably one of the more challenging sections in the whole class due to just how complicated the problems get, how many steps there are involved. So find the area of the shaded region. So we have to realize it's going to be the circle minus the square, because the square is inside and it's got a side length of 8, so all these are 8. So if we want the area of the circle, we need to know pi r squared, so something's missing here. We don't know the radius. Let's call this radius. But then the square I can find pretty easily. That's just 8 times 8, so 64. But now I should really, what's going to help is to draw in this entire diagonal, which we can call the diameter of the circle. And then we get this isosceles right triangle. And if you remember a shortcut, to find if we have an isosceles right triangle, if this is the same, then the hypotenuse is always x root 2. So that means the diameter of this is, let's call it d, is 8 root 2. So then we just want to cut this in half and get 4 root 2 for the radius. Then we can, actually, what are we going to do with this number, 4 root 2? We're going to plug it in for this r, which means we're going to square this, which means 4 root 2 times 4 root 2. And now you don't really have to do this, but you might find it's a little bit easier than using your calculator. This means we just do 4 times 4, and then root 2 times root 2, which is just 2. So then this is actually doable without the calculator. It's 32. So that means we have 32 times pi minus 64, which is actually the exact value of this if we don't use a calculator. And it sets us up easily to go to our calculator. However, if you don't understand this method to get 32 and you want to go to the calculator, let's bring this up. If you get to the 4 root 2 step, or maybe even you had something different, we can go through that in a minute, you get this number. And we definitely don't want to round this because we're going to square that. So the easiest way on this beast calculator is to just do this. Answer squared. Bam, 32. If I round this to like 5.66 and I square that, I am not going to get 32. I'm going to get a little bit too much. Or if I round it to 5.7, I'm not going to get 32 either. The only way to get 32 is to keep all these decimals, because the calculator is recognizing that as the exact value. So one other way you could have done this is back to the right. So let's say you forgot this this rule. Then you could have just done 8 squared plus 8 squared equals d squared, right? And then 64 plus 64, and then that's 128, and then take the square root. What's the square root of 128? It's that 5.65, and so on. So you could do it that method also. But then make sure you're going to square this entire number to get 32. Now we go to the calculator and calculate our final answer, 32 pi minus 64. And round 36.5. To make it even more challenging, I could ask you to round to 2 decimal places to make sure that you're not rounding too soon. And we should say meters squared because it's area. Okay. Next problem, we'll just do one more, which is another really challenging one, even more challenging than this. And so we've got this familiar diagram with 2 tangent lines. They hit the radius, so this is a 90-degree angle, and we get a kite. So you might think, okay, how do we find the area of this? We should take the biggest shape, which is a kite, and minus this white sector. We can find both of those. The problem with the kite is you need to know diagonal 1, which we could find, but diagonal 2 is this one, which is pretty hard to find in this case. So we kind of want to rule out the kite. And instead, let's look at this in a different way. We still want those right angles. And we still want this long diagonal, but notice what happens. What kind of shapes do we get? We get right triangles on either side. So we could find the area of the two right triangles, and then minus the sector. And that's going to actually be a little bit easier, because what we're given is this 8 root 3, which is HA. And these triangles are the same on both sides. So this should be a hint that we're going to have to use a 30, 60, 90 right triangle, because this is the side opposite 60. And that means that 8 is the side opposite 30. And that means that 16 is the hypotenuse. Not that we really even need that. So this is 16, this long diagonal, and this is 8. You have to be able to come up with at least one of those. Maybe not both, but if you come up with at least one, then you can use the Pythagorean theorem to get the other one. But really, we don't need this 16, because the base, let's call this the base and this the height of that triangle, because it's a right triangle. Maybe we draw it like this instead, where this becomes 8 root 3, and this is the 8, and this is the 16. So find the area of that triangle. We just do base times, or I guess this case would be base, would be 8 root 3 times 8 divided by 2. But then we want two of these, this one and this one. So we might as well get rid of this. Just do 8 root 3 times 8. 8 root 3. Notice I don't even have to type in times, but then I have to do times 8. So about 111, but we don't want to round yet, because now we have to find the area of that sector. So I'm just going to write down that answer, 110.85, about, for the two triangles. 110.85. So then the sector, we need the, let's ignore this, x over 360, and that's the measure of this central angle. So if I get rid of some of this stuff so we can focus on this sector now, this white part. Okay, the central angle of this sector is 120. So I do 120 over 360, which is exactly 1/3, times the area of the whole circle. So I need the radius, and I have it. It's 8. Okay, so then I just do times 64 pi times 64 pi, 1/3. So I could do 64 pi divided by 3. And now I'm going to subtract that value. So I can do 110.85. Just to be a little bit more accurate, I'm going to use 2 decimals. I could even do 3 minus 67.02, just to be a bit more accurate. And then 43.8 or 43.83, depending on how I have you round this. Let's just say 43.8 about. And then the units are centimeters, so centimeters squared. Okay, that's it for this section. This is, like I said, going to give you some of the most challenging problems. So they're combining the 30, 60, 90 right triangles mostly, and other things that we've done using circles and sectors and kites and triangles and all kinds of stuff.